Ever looked at an old map? Like a really old one? You'll probably see sea monsters, maybe something about dragons, and if it's the right map, there will be a name along the northern edge. Thule. It was a place more imagined than seen, a symbol for the absolute limit of exploration. But that mythical land isn't just a footnote in your history books. It's hiding in plain sight on the periodic table. Hello and welcome to Meet the Elements, the series where I take a look at the stories of humanity through the lens of the periodic table. So element 69, Thulium, is named after a place that sits on the border of myth and reality. It's a clue that points to the story of scientific struggle and a journey to the frontiers of chemistry, where scientists were as lost as ancient mariners were in uncharted waters. So why would a scientist name an element after a land of legend? This is the story of the element named after a mythical land and the brilliant minds who went to the edge of their own world to find it. To begin our story, we return to the 19th century and the boom of chemical understanding that came with it. The periodic table, laid out by Dmitri Mendeleev, was a brand new map of matter, but was a map with tantalizing blanks. Labs all across Europe were scrambling to be the first to discover the missing pieces and secure their scientific legacy. In this feverish environment, one group of elements was a chemist's nightmare, the lanthanides, also known as the rare earth elements. Back then, they were a mess. They were found hiding in strange minerals, often from a single mine in a tiny Swedish village. But I'll save that for future episodes. These elements were a puzzle unlike any other. The name rare earth is actually a bit misleading. Earth referred to the fact that these elements would only occur naturally in compounds rather than their pure forms, and they were rather difficult to break down. Rare refers to the expense needed to isolate one of these elements rather than their scarcity. The expensive isolation comes from the fact that lanthanides are so chemically similar, they're nearly impossible to tell apart without specific techniques. They clump together in nature, and trying to separate them was like trying to unscramble eggs. For decades, chemists would announce a new element only to have it revealed as an impure cocktail of several others. It was a field filled with frustration, and it's this chemical chaos that set the stage for Thulium's discovery. Our hero isn't a flamboyant showman, but rather a meticulous Swedish chemist named Teodor Cleve. Working at the University of Uppsala in the late 1870s, Cleve was a master of the rare earths. This was a guy who had already helped prove that helium existed on Earth. He knew how to find things that were well and truly hidden. His attention got stuck on a pinkish substance called erbia, also known as erbium oxide. Most chemists thought erbia's secrets were tapped out since other elements had already been pulled from its mineral family. But Cleve saw an inconsistency in the atomic weights of samples, varying based on where the sample was sourced. To anyone else, it was noise. To Cleve, it was a sign that something else was hiding in erbia. So he started the painstaking work, using a process of partially dissolving the material and removing the known purities first. As he kept working, he saw that the material was slowly separating. As Cleve kept going, further refining his erbia sample, he realized he hadn't just found one new thing, he'd found two. After all his work, he had two new substances isolated from his pink oxide. One was a brown substance, and the other a faint green. The brown substance I'll get to in a future video, because it was the green stuff that was the real treasure. It was fainter, more elusive. This Cleve knew was a brand new element. He called its oxide Thulia, and the element itself Thulium. His discovery was a triumph of pure persistence. It was a victory won through careful, repetitive steps, all guided by the belief that something was hiding beyond what his peers could see. Which brings us to an interesting question. Why that name? The name comes from Thule, the earliest name for Scandinavia used on ancient Greek and Roman maps. It was a land shrouded in fog and legend, representing the absolute limit of exploration. The exact location remains a debate, but it was always the northern edge. For Teodor Cleve, a proud Swede, the name was something perfect. He had just navigated the most confusing and difficult region of the periodic table. He had pushed past the known boundaries and found something nobody else could. But the legend of Thulium's difficulty was far from over. Cleve had proven it existed, but what he had was just a trace amount, and still impure. Getting to the pure metal would take a journey even more epic than his own. The story now jumps across the Atlantic and forward several decades to the British chemist working in America, Charles James. He was a legend in his own right, developing a method for purifying rare earth elements through fractional crystallization, the very method that allowed him to purify thulium. What he did might be hard to wrap your head around. This fractional crystallization meant dissolving the material and letting it slowly crystallize out, hoping the slightly different elements would separate at infinitesimally different rates. For Thulium, he had to do this again, and again, and again. It wasn't 100 times, it wasn't 1,000. Charles James famously performed 15,000 recrystallization operations to finally get a pure sample of thulium in 1911. That staggering number shows you the whole problem with the lanthanides. Their similarity comes from the weird nature of f orbitals and a phenomenon called lanthanide contraction. As you move across the group, the atomic radii of the elements greatly shrinks, more than you would expect. This keeps their chemical properties nearly identical, making them incredibly difficult to separate. Today, thulium is more than a chemical curiosity. Even though it's the second rarest of the rare earth elements, we've been able to find some remarkable uses for it. Its properties make it useful for creating high-efficiency lasers, which are used in delicate surgeries. On top of that, if you put stable thulium in a nuclear reactor, it turns into radioactive thulium-170. This isotope gives off a soft type of X-ray, making it perfect for small, portable X-ray machines that can be used far from any hospital. From a green smudge in a Swedish lab to a tool that can save lives, thulium's journey is extraordinary, and its name is a reminder that the names we give the elements are not random labels. They're a diary of human history, culture, and our eternal quest for understanding. They tell stories of pride, of gods, and of journeys to the farthest reaches of our understanding. And thulium, the element named for a legendary land at the edge of the world, will forever be a symbol of that quest. The relentless drive to take what is myth and make it real. Thanks for watching. Once again, I'd like to thank viewer MomoPandas9242 for suggesting I take a look at the lanthanides. They specifically mentioned thulium, and I thought it was a good place to talk about the similarity of the lanthanides. But rest assured, the difficulty of the lanthanides isn't over yet. But now I want to hear from you. What do you think about the profound symbolism of thulium? Or maybe you feel I left something out? Let me know down in the comments. And while you're down there, make sure to leave a suggestion for the next element you want to see me cover. And if you want more stories about insatiable human curiosity, make sure to subscribe so you don't miss the next episode of Meet the Elements.